Hello there and welcome to this course on Introduction to SQL. In this course, we're going to learn about SQL. We'll learn what is SQL. We'll learn why you would want to learn about SQL and as well as why you would want to use it. We'll also learn about when to use SQL. And lastly, which we will spend a lot more during this particular course, we'll learn how to write SQL queries. And more specifically, we'll get to create and delete tables, be able to insert data into those tables, be able to select data, be able to update data, as well as being able to delete the data that will be in those tables. So let's get started. Starting off, SQL just stands for Structured Query Language, and it's a powerful programming language for managing and manipulating relational databases. For just clarity, relational databases are a type of database that you would use to store data in a tabular format, as opposed to any other format that might be out there. It could be that you might want to store maybe data with regards to users in a tabular format where you have first name, last name, as well as some other related information in a table format. Then a relational database would come in handy. If you want to store data in other different kinds of format, which could be maybe graph format, where you store data in what are called nodes and relationships, then you would use other types of databases, not really relational databases. And they're different. There are actually multiple other types of databases. Could be graph databases, document-oriented databases, columnar databases. There are different other types of databases. But the reason why you would want to store data in a relational database is because it allows many stakeholders to be able to easily access that data, because they have knowledge on how to retrieve that data. In addition, you might also want to store data in just an easy format, and a relational database would allow you to just store that data in an easy format, which is just tabular format. So with relational databases, in order to be able to select data, to store data in that type of database, then you would need to learn how to work with SQL, which is a programming language that basically allows you to interact with relational databases. There are other languages that you can use to interact with different types of databases. For example, if you wanted to work with a graph database where you store data in the form of, let's say, nodes and relationships, then in such a situation, you would work with a querying language for those databases, which is this one that's called Cypher, which is another language by itself. But again, the reason why we would want to work with relational databases is because many organizations already use relational databases to store data, and these might be tools like MySQL databases, could be Postgres, it could be SQLite, it could be Oracle DB, MS Server, as well as many others. So yeah, so just that's the idea, just to give you a quick overview of why we would also want to learn SQL. I think something else, just to give you some good definition. So a relational databases is a collection of tables that organize and store data in a structured manner. So that is another key concept that you also need to take into consideration before you now go deeper into now working with SQL. It doesn't really make sense for you to go into SQL while you still really don't have a good idea of exactly how SQL fits into the big picture. Now, when we work with SQL, the language itself, we tend to write code. We actually write code. And this code you can break it down in what is called queries. So when you're writing SQL code, you basically be writing queries that allow you to be able to select data, queries that allow you to be able to perform other also tasks to a relational database. It could be store data, it could be update data, etc. So what you see on your screen basically is a basic SQL structure in terms of a query. So a query would look like this, where you have what is called a select statement, and you would be selecting data from a particular table, taking into consideration of some conditions. So select all columns from, then you name the table name that you want to select the data from, then use this particular clause. It's called a where clause that helps you to define the condition that you want, maybe where age is greater than maybe a certain number, etc. For data scientists, just to also give you some good clarities, for data scientists, it's important that you learn how to use this particular select statement, considering that you would be sourcing for data from different relational databases, if not one. And most of your work will be just around this particular type of statement. But for other types, for other persons who want to become maybe data engineers or data analysts, it's important that you not only learn how to select data, but you also learn how to create the databases, how you need to design databases efficiently, how you would need to also learn how to insert data, update data, delete data, as well as also be in a position to modify your tables if there's that particular need. So a select statement would look like that. The select, and you have different components of this select statement. Like for example, you have what is called a select statement, which just we use it to specify the column or columns you want to display. We then use the from, we call it a command statement, to be able to specify the table that you want to retrieve the columns from, as well as using what is called a where clause to specify the conditions for the data you want to retrieve or display. So if you understand this, then this structure, then when it comes to writing code, SQL code, it's going to be a whole lot easier. The other different types of common SQL statements is the select statement that you write, insert into statement, update, delete, create table, alter table, and drop table. And for select, you retrieve data from one or more tables. Insert, you insert records into those the table that you want. Update, the same case. Delete, you remove. Update is just modifying existing records if you want to do that. Delete, if you want to maybe remove records from a table. You want and also if you want to create a table, you can do the same thing with a create SQL statement, or alter table, or drop table, with just different types of operations. As mentioned, for data scientists, this is usually more than sufficient this is usually just sufficient learning how to work with select statements. But for other professions, if you want to become maybe a web developer, software engineer, or data engineer, then you need to learn more about these other queries, because your job will be revolving around maintaining and optimizing the data sources, or the architecture of those data sources. And that is, these commands will come in handy. As well as by the data scientists would also be focused also just working on select statement. There are clauses that you use also together with these particular statements, also the select statement, where you would specify, you would provide some sort of condition to your query in order to be able to pull the data that you want. For example, you would use a where clause to filter rows based on specific conditions. You would use the order by clause to sort data that you have selected. Group by to be able to group rows based on one or more columns. If you have an idea of what are pivot tables, so you can be able to create some sort of pivot table or summary table using a group by clause. You can also be able to work with having clause, limit, distinct, and in clauses to just specify exactly what you want with your complex scenario from the data source, the relational data source that you want. Something else to note is that you would also need to take into consideration of the type of data that you're storing in a relational database. Mentioned you store data in a relational database in what are called tables, and in those tables you have columns. And data comes in different formats. You could have numeric data, you could have date, time data, you could also have what is just character data type. So you just store just characters. Maybe you might decide to store maybe something like just some text, like your first name. So you might want to ensure that you have specified the first name should not be longer than maybe 200 characters, just for efficiency purposes, as well as learning more about how to use Boolean data types. So these are just some common data types that would come in handy in the course of your career, whether it's becoming a data engineer or software engineer. These are quite important. For data scientists and data analysts, yes, it's important, but not as much as what data engineers would be doing on a day-to-day basis when it comes to just creating relational databases and ensuring that they are optimized for just taking in different types of data. The other concepts that you need to learn, which are operators. So these are just components within your SQL queries that allow you to also apply some sort of condition. So in your condition statement, so in your condition that let's say you write at the end of your query, you might want to use an operator that helps you to pull the data that you want. Say you want to select data where the age is less than, so you would use a comparison, less than comparison operator to be able to specify that. And there are other comparison operators depending again on the situation. There are arithmetic operators that you can also use to just maybe combine two columns and be able to also at the same time apply that in condition and use in conjunction with comparison operators to pull some sort of data that you want. Other types of operators that might come in handy, logical operators, could be that you not only want to pull data where maybe one column, let's say age is less than 50, but you also want to pull data where another column, maybe the gender column is male or female. You could do something of that sort with the logical operators. So these are just different also types of operators that just help you to just get the data that you want from the database that you are going to be working with. Lastly, when it comes to working with SQL, especially on the side of designing and optimizing, you would need to also learn how to establish appropriate relationships such that you do not have duplicate data across tables. So you might have maybe first name, last name in one particular table and an ID still in that particular table, but you don't also want to duplicate to have first name column appearing in another table. Instead, what you want to do is to have each and every table contain just unique data and reference each other table, every other table through what is called a primary key, which generally would help you to just link the different records across multiple tables. Other things that you might want to consider are what are called using index columns, which are quite useful for just searching and sorting and joining tables. If you want maybe even to retrieve data, having index columns usually helps. Using also appropriate data validation checks on the side of design, so ensuring that when you create a table that will be taking in data maybe from different sources, whether it's from maybe a web application or someone who's inputting data manually, the table will only accept data that you have specified. Say, for example, for first name, if the data is more than 100 characters which you had specified, then that will be rejected by the database, relational database. considering that maybe you might realize in your use case, in your scenario, you should not expect data that is beyond that, maybe data that is more than 100 characters, which would be flagged as invalid. So the other different techniques that you might want to also explore, aside from what we're going to learn in this session, but that is usually dependent on a tool. So for instance, if you want to use, say, something like maybe, how should I put it? If you want to use something like a MySQL database, it's important to also look at what is called the documentation, which is just a manual to see what recommended measures in terms of optimization do you need to take into consideration when working with that kind of a database, as well as also taking into consideration these security measures. All right, so now we're going to move on into our practice work, which will entail going through what is called just a notebook. So the approach that we're going to be using with regards to working with SQL practically is one that involves working more as a data scientist or a data analyst than a software engineer or maybe a web developer. Our focus will be using a notebook environment to be able to pull data from a particular database and be able to create queries and interact with those particular tables that you have in your database. It's important that if you want to become a data scientist or data analyst, you familiarize yourself with this notebook environment, which is what we're going to be using. I'll explain that in a bit. But at the same time, if you are software engineers, don't mind so much about why we're using this particular environment over maybe using just Python locally in your machine. The idea is that you have a grasp of how to write the queries that we've talked about. That's the most important thing. And you can be able to apply that knowledge in whatever context. And it also doesn't hurt just getting to also be introduced to this new environment. Same. One more thing is that we're going to be using a notebook, and we're also going to interact with SQL using a bit of some Python, but not much, just a bit of some Python. But our focus majorly on this during this particular workshop will just be on generally working with SQL. So that is just something to note. It's a language again that you use. Python is a language that we normally use for data science work, data analyst work, or even software engineering. So yeah, I've shared this link in the description section of this video. So just have a look at that. Just open that link and you should get to this particular page. It's a notebook, which generally is just a document that contains analysis of what we are going to be doing. All right, so to get started with this notebook, once you have gotten to this page, what you need to do is to make a copy of this notebook so that you're able to make changes and have those changes saved in your computer. So what you're going to do is going to File, then Save a Copy in Drive, and this should open a new tab that will contain the notebook that we're going to be working. So if I click on Save a Copy in Drive, I should have a new tab that will have a copy of this notebook. The reason is because this is a master copy, so you don't want to apply changes to this particular copy. And if you apply changes to it, you won't be able to access it. By the way, you also need a Google, a Gmail account to be able to use this particular notebook and also save it. The notebook that will be saved, will open in a new tab, will be saved in your Google Drive. So that is something just to take into consideration. So let's just quickly get started. This notebook has been divided in different sections, and there are challenges as well that you can attempt. So this is just content that we curated for you to just be able to go through the different concepts that we need to go through in terms of SQL. Right, let me just get started. I'll just open mine in playground mode. You don't have to do that. It's because I don't want to make changes to the original copy. But yeah, so I have now mine in playground mode, and I can be able to just work on this and show you how to go through the different sections. Now, starting off, we're going to learn how to access a database when it comes to Python. This is a notebook, by the way, and it usually contains different cells, two types. It usually contains cells. So there are text cells and code cells. What I've clicked here is a code cell, is a text cell, and this is a code cell. The code cell will just contain code, our code that we want to run, and the text cell will just basically contain just text and any sort of media that you would want, but you wouldn't be able to run the code here. So the first thing that we would need to do in order to interact with SQL is to connect to a relational database. There are different kinds of relational databases. There's Postgres, there's MySQL, there's different kinds of them. But for our use case, we are going to be connecting to an SQLite database, which is it's a lightweight database that we can be able to access. That's provided on Google Collaboratory. So Google Colab is a tool that it's actually a version of a notebook. A notebook is just generally a document that contains analysis and code, and normally data scientists and data analysts use such. So the first thing that we are going to need, let me just zoom in a bit so that you're able to see what's happening. Let's do it again. All right, I think maybe I'm not sure whether that should be good. I think that's good. Right, so the first thing that we're going to need to do is to connect this notebook to Google servers. So we're going to click on this connect button. So click on that, and our notebook will be connected to Google servers where our code will be run. So once we have done that, we're going to use just Python to connect to that SQLite database that we want. And we would normally do this. We first of all import what is called an SQLite library, which would generally allow us to connect to an SQLite database, relational database. You can also do that for different types of databases. So you have this for SQLite, but you can have the same for it could be not only this, it could be should I put it? It could be MySQL, Postgres, there could be Oracle DB, etc. So this is what we're going to first of all use to import the library that will allow us to interact with our SQLite database. Then we create a connection to that database. Now, our database, the SQLite database that we're going to be using, is a in-memory database provided by Google Colab that we will use for just learning purposes. And then with Python, once you have connected, we normally create what is called a cursor object that we can use to run our SQL queries on. And we can be able to use this cursor object to execute the queries that we want. For example, in our situation over here, we're able to use the cursor object to and also the execute method to be able to execute this particular query, which is what you're seeing on your screen here. So first of all, let's click on this particular icon that you see over here to be able to run this particular notebook. You might get this if you haven't this warning if you haven't created a copy of this notebook, but if you have, then it's okay. Let's run anyway. And then once we get here, so it has run our code has run successfully by simply having this green check on the left of that cell. The next thing that we need to do is create a table that we can use. So we have already connected to our SQLite database, and we can now be able to write queries in order to store data, for example. And before we can be able to store data, we need to create tables. We need to create a table to store data to. So the first thing that we're going to do is to create an SQL query. So to write an SQL query to create a table. So we use the create table statement to be able to do that. And then what follows, so These are actually what are called just commands. The individual components, they're just commands. They're also clauses, but for now, what we have in full here is an SQL statement, a create table statement. So we can even call it a command, or you could also call it a keyword. This like create table is just a keyword, an SQL keyword that we can use to write our data, to create our database. To look, it's a keyword that exists within an SQL query that we can use to perform different operations. So for create table, just helps us to define the query that we want to write. So we want to create a table, then we say the table name, that's students. Then we define what's inside the parentheses is the different constraints for this table. We want this table to have these columns. There's the ID column, name, age, and grade. And these, they will allow the ID, name, age, and grade will appear as with the column names as you see them here. Then there's integer. So these ones are the data types that I had mentioned earlier. Like for example, for the ID column, we want to have the values, integer values for this particular ID column. We also want to have this particular ID column as a primary key. So in other tables, we might want to create a student's ID column that will contain values that will be referencing to this particular student's ID column. Then we have name column that generally would store data in the form of text. It may not be the most optimal or the best data type in our situation, but we can still use it to just specify that we just want text in here, which can take any numerical or non-numerical data. For the age column, we might want to use integer, the same case grade text. But the same case here, again, this may not be the most optimal, but the idea is just to learn how to also work with data types in our situation over here. So running this will just create a students table that we can now later populate data to. So yeah, so that is it with regards to students table. Now work on the challenge, and then once you have worked on the challenge, then you can be able to move on to the next section. By the way, we've provided some hints. Hints are just actually they're solutions, not really hints, but try as much as you can not to look at that particular hint that comes after the challenge. So you can write your code here, but ensure that you write it in this format: cursor.execute. Then you have these three characters, these two sets of characters. Then inside you have specified your query for creating a table. So I'll also write it. So, well, I don't want to write it because of time, but you can do that. But this is the answer for that. Though you need to have it inside cursor.execute, the method itself, the execute method. Now, when it comes to inserting data into a table, you would need to specify with the columns that you want to insert data to, as well as the values that you want to insert data to. So for instance, in our situation, insert into students, this insert into is, we use these keywords to specify that we want to insert data into the students table, the table that we want. And then we define inside the parentheses that comes next after the table name, the columns where we want to populate data to, and then we specify the data that we want. Note that the text data, we have enclosed it in quotes, while the integer data or any numerical data, we'll just leave it as it is. So in our case over here, we are running all these commands to just insert these records into our table. About 10, yes, there are 10 records. So again, work on the challenge and ensure that you use this particular format that you see here in order to insert your table. Now, something else to note while you're working on this particular challenge is that we have one line over here of cursor.execute, but on our situation over here, we have multiple lines. And whenever we're using multiple lines, we decided to use the three called delimiter characters. You can see three quotes, single quotes, and close our queries in 3 single quotes. But when you have one particular line, you have a single quote. So ensure that you also do the same thing for these particular records that you see here. The answer will look something closer to this, but now for employees table. This is just a hint for just giving you an idea of how you do it. All right, so if let me run this to be able to store data in our students table, and I have been able to do that. Don't worry about this. This just prints out the cursor, which really doesn't have any, which actually we haven't been able to print out. It actually doesn't give us meaningful information for now, but we'll get to see how we can also print out those records that we have stored in the table in a few. Now, if we want to retrieve records from the students table, we will just again say cursor.execute, then specify our select query or select statement where we want to select data from. So select star from students. So select command, and the select keyword would specify that we want to retrieve data from this particular table, from actually whatever comes after this from keyword specifies the table name. Then the star here would actually mean that we are intending to select all the columns from this particular table. If we had some sort of other condition that comes after students, let's say where something, maybe where maybe situation name is or age is greater than or less than, then we would have a limit in terms of the records that we retrieve. But in our situation over here, we would be selecting all the records because we haven't specified anything. So we would get all the columns as well as all the records from the database. And then once we have been able to, we would just define what we want. But once we have done that, we would fetch all the records using this particular line of code. Still Python over here, but now we are working still with Python and SQL. And then we would print the fetched records onto this particular notebook. So we would print the records which we have fetched and use what is called a for loop in Python to be able to iterate through the result, because what will be fetched would be all the records, which you remember here, they were 10, but now we want to display them. We normally use a for loop in Python to be able to iterate through or to go through the list and be able now, let's say, define that we want to display. So this particular print function over here just states that we want to display the individual records in a particular list of records that we fetched. And you can see these are records that we had from the students table. So work on this other challenge, retrieve all the records from the employees table and just display them, just more like what we did here. By the way, you could always even just simply copy this particular code and then paste it in this cell and be able to just modify just a few things. Select star from employees, and you should be able to have that. Select distinct. So assuming that you have some duplicates in your table, you might want to take that into consideration. You just don't want the duplicates, you just want the distinct grades of records from your table. Then you can use the distinct keyword. So in our situation, say distinct, select, then distinct. But now we specify what do we want to be distinct in our table. That's in terms of the records that we want to select. We want to ensure that the records that we get have a distinct grade from the students table. So this is how we're able to apply the same thing. So select the distinct and grade from students. And in our situation, actually over here, we're going to be able to select the distinct grades only from the students record. So that is what we are going to get. All right, work on the challenge, the employees table challenge, and then we move to the next section. By the way, you could always pause the video if need be. In our situation, again, over here, we might want to select maybe some records with, and also take into consideration some conditions. Say, for example, select all the columns from students table where the name column is equals to Emily. So we should be able to do that and be able to get that as a result. So a where clause allows us to be able to apply conditions. And this can also be applicable not only to just textual data, you can also have numbers. But for numbers, you don't enclose them in the quotes that you see here, single quotes. Sometimes it could be double quotes, which is still the same, which is okay. Work on the challenge. You can pause the video and then continue. And or not. So in our situation over here, we might also work with those other operators that we had mentioned. So assuming that you wanted to say select all the records from the students table, again you want also to select all the columns by defining the star, where grade is equals to A. So grade is in the grade column there's the A value, and also age, the age column has values greater than 20. You can also do the same. So we are using this and particular operator to be able to perform the same thing. We could also use or to just define to retrieve the records if either of the conditions turn out to be true. If this particular condition is false, we could also assess to check whether this other condition is false. So we use an or to check whether either of the conditions is true, and we use the and operator to ensure and to retrieve records where both conditions are true. For this other one, not operator, we can use to select records which don't have the specified conditions. In our situation, all the grades which do not have a grade of equals to A will be selected. So let me run this. For ages A, no, age grade is A and age is greater than 20. That's the record. The same case here, I think that's okay. If I run this, you should be able to see that. You can see that either age is A or grades is less than 20. Either age is A, or like in our situation, age is A, but if age is not A, it's B. But no, grade is B, but if and grade is not B from the condition, so we say that we want to check whether age is less than 20, etc. The same case, select star from students where not grade is equals to A. So if all the records that don't have the grades as A, you can see here. All right, work on the challenge and then let's continue afterwards. There are actually 3 challenges. Order by, we might want to order the result. So in our situation over here, we might want to order a result in a certain way. So either ascending or descending. And we just use, not even ascending or descending, sorry, that's sorting. We might want to order them probably, yes, it actually is ascending or descending, but now we might want to order them by a certain column. So in our situation over here, we might decide to specify that the name column needs to be ordered. The values need to be ordered by the name column, and now in ascending order. But again, you could also specify whether it's ascending or descending. By default, if you don't specify, say whether you want it to be ascending, like the way we have here, we could specify by saying ASC, then we would have still in ascending order. So if I run this, I should be able to see my records over here, which actually we select the name column only, and they're all ordered by name column. So all these are arranged in alphabetical order from A to Z. We can also do the same thing, just specify descending order. All right, work on the challenge and then let's continue. Update. We might want to update a record with probably some value. Now, this is we finished actually selecting. So as a data scientist and a data analyst, I think some of those things that we've done there should be sufficient enough for you to move on to the next stage in terms of maybe working in projects in relation to SQL. And actually this notebook gives you an easier way of just putting data. So in terms of updating data, so assuming that you want to update data in a table, so you might want to use the update, you might want to write an update statement. So update, use update keyword, the table name, and set grade to equal to A, where ID is equals to 2. And once you have written this particular command, you can say fetch all records from students after the update. So once you have updated, you can now also fetch the records to just check whether you have made that particular update. So in our situation, we are updating, sorry, just to clarify, we are updating our students table where the ID is equal to 2, the ID column, the ID value, and is equals to 2, and we are setting the grade column to have this particular new value that we want. So again, once we do that, we execute that, and then we fetch all the records from the students table so that we can see whether we have made that change. This statement over here just helps us to just separate our output to see what's happening in our output. So records after updating will be actually what we will see. So where ID is 2, where ID is 2, which is the first one, we set our age to our grade to A. Right, work on that challenge, and then let's continue. Deleting a record from a table just goes to how you're able to, if you want to maybe to delete maybe a certain record where there's a certain condition, so you can say delete from students where ID is equals to 1. So you need to specify using a where clause which record you want to delete. And again, you could also add some other conditions. You could use and or operators, comparison operators too. So you could also use actually those operators, logical operators and comparison operators to create your condition expressions there. And we can delete from students where ID is 1 and now display the records of the deletion. So we don't have a record with an ID of 1. We have just from 2 to 10. All right, work on the challenge, and then let's continue. We can also be able to select a query and retrieve. For instance, we might want to also we might want to have, we might have maybe a complex scenario where we want to maybe select maybe minimum age in that records with a minimum age in that particular table, and this is how we can be able to do that. But now in our situation here, we're only selecting the column. Remember, what comes after the select keyword is now the column that we want to select, but now we just want to select the age. Like we're performing a calculation to select just the minimum age from the students table, and we define the column that we want to apply this operation to. So we will get the minimum age from that table, which is 17. The same case, the maximum age, we can also do the same thing and get the maximum age 21. All right, work on the challenge, and then let's continue. Count, average, sum. These are other functions that allow us to, we can just call them even functions. Just they allow us to perform just some complex operations. So for instance, if we want to count how many records we have in a table, we usually use the count function, but now we specify how many, we specify the columns that we want to perform the count function on, and to be able to retrieve all the records by just simply specifying that that in our SQL query is shown. So select count star from students. And again, you could also specify conditions if you wanted. So in our situation, we have 9 records from the students table. We have 9 records. Remember, we deleted one. Don't forget about that. We can also calculate maybe an average, like with what we did with minimum and maximum. We might want to also calculate an average of a particular column as shown. Let's use the average function. And in some situations, we could also use other functions to also get a well-rounded result we want. Okay, aside from the average, we could also decide to find the sum of all ages. It may not be some useful information, but for some columns it might be. Maybe if you had a column that had maybe balances in an account from different records, then you could do something like that. But this is just for learning purposes. Right, work on those challenges and then let's continue. Group by. Group by, we normally use a group by clause to be able to create some sort of summary table. So assuming that we wanted to create a summary table where we have grade as well as the count of those particular grades in that particular record. So if this summary table would have grade as well as the number of grades, whether it's A's, B's, and C's in that table, then we can use this particular method. So if I run this, I should be able to see that we have 5 A's, B's, and C's. So what we do is that we specify first of all the columns that we want in that summary table, and then we say the table that we want by using the from then group by. We just want to group by that particular column, which is the grade column. Then we just fetch those records as you can see. Right, work on that challenge and then let's continue. Like we can also use the operator like to be able to specify where say a record starts with. It's usually useful when it comes to matching. Maybe you want to use you want to check whether there's some records that have maybe a certain number of characters inside those particular values in that column. So in our situation, we can use a like operator to be able to check whether maybe a particular record, maybe first name, starts with a certain character. So in our situation over here, we might want to select from the students table where that record has or starts with the letter S, as you might see here. We could define it with another maybe characters. If it's multiple ones, S, E, E, or whatever that we want. So we also use a wildcard. A wildcard is just it just allows us to be able to specify how we want to have in terms of how we want to search our values in the column that we want. So we can be able to see like records matching the condition as you can see here are Sarah, and Sophia. So if I change, if I want to see Sarah only, I can say SA, and there's only one record that should come up with Sarah. So there's something to note. When it comes to the like operator, again, we can also use the underscore wildcard, and this just helps us to be able to define whether a particular value in a column has, for instance, a number of characters that we want. For instance, if we wanted to check whether in the name column we have values with 4 characters, or maybe the second character is an A. So in our situation, we might want to use, let's say, double quotes just over here. Then this is the first character, this is the second character, this is the third character, and this is the 4th character. So in our situation over here, the underscore just helps us to specify any character. But if you want a specific character, you might want to say maybe where the first character is an S. So like, for instance, double S. So for instance, capital S over here will be Sarah, will be matched because no, it wouldn't be matched because it has 5 characters. But if I put another underscore, we now have 5 because if I 1, 2, 3, 4, 5. So the output I should get is still the same case over here as Sarah. But if I remove one wild character, which is an underscore, I won't be able to get any sort of result. So ideally, this particular situation can be useful for some complex situations that might come in handy, and you can be able to just play around with those wildcards. Just run that. All right, work on that challenge, and then later we'll continue. Between operator, we can use again this operator to specify. Let's say we want to only retrieve records that have age values between 18 and 20. Which could be useful for analysis, maybe to study maybe a subset of users. Then you can be able to use the between operator. So you said between then 18, then you also use and then 20. You should be able to get that as a result. As you can see, there's 19, 20, there's 18, etc. And this also just includes also the actual 18 as well as 20 which you have mentioned. All right, so I think that's where we have gotten with regards to this particular course. Just work on those challenges. There are also other challenges that you can get to interact with. So we've gone through what are being able to create a table, insert data into a table, select records, select distinct records or values, use a where clause, and or not, order by, update, delete, min, max, count, average, sum, group by, like, between. So the next thing that you can do, just work on these challenges, and the idea is that by the end of it all, you should be in a good position to undertake some complex projects that you can always undertake. And all the best in your learning process, and feel free to hit the like button if or like this particular course, so that others can also be able to go through it and also get some value from it. All the best.